Hey, algebra students, let's tackle a challenging example of solving equations together. So let's take a look. It says 3 students solved the same equation incorrectly. Identify the common student error in each solution, then find the correct solution. So this type of problem does occasionally occur on the GED where you're shown a solution on the GED test. And if that happens, then you'll probably just need to pick out which step they made the error in. So you just will probably need to figure out where it is, not what exactly went wrong. But I want to look with you today about what exactly went wrong because these are 3 really common student errors I made with each of these. These are the ones you guys usually make. So if we can see why they're errors, hopefully I can help you not to make them when you're solving equations. So just staring at another student's work can be really challenging. Even as a teacher, I struggle with that. So I think what I'll do here is I'm going to write down this same equation that Katie solved. I'm going to put it right next door so that we can compare what we would do with what Katie did here. So if I were looking at this equation, negative 41 is equal to 15 minus 4p. This is one that I know a lot of students struggle with because of where the letter is. So a really good test-taking strategy, or just even an algebra strategy, I should say, is to write a line down that equal sign so your equal sign stays steady and you can tell the left-hand side from the right-hand side here. You can see that those are 2 separate expressions. So now it's easy to see where P is the letter in this case, so that if I want to solve this and get this alone, I know that I need to move 2 numbers over. I need to move 15 and negative 4. Now, a lot of students remember for me, and I appreciate that if you're solving an equation, we're moving numbers across equal signs here, then we are going to use opposites. And so even the order of operations will move backwards. I need to move what's adding and subtracting first. Okay, but what a lot of students can't tell is what's adding or subtracting here. So remember, the key is what the number is doing with P. Okay, so take a look at the 4. Do you see how it's shoved up against the P? Even though this number says minus 4 or subtract 4, because the 4 is shoved up against the P, the 4 is multiplying with the P. But notice how there's a minus sign between the 15 and the 4p. That means that 15, see, there's something between them. That means that that 15 is a term. It's something adding or subtracting. It's a term. That being said, though, a lot of students do exactly what Katie did. They see the minus sign and they say, ooh, let's pick out red, because this is going to be really wrong. They see that minus sign and they say, oh, I'll plus, and I'm going to plus 15, and then I'll do that to both sides. And that's what Katie did. And I told you guys, you can do whatever you want to an equation as long as you do it to both sides. So what's so wrong about Katie's method? Well, let's just actually follow through with it. Let's do what you said you were going to do. And I'm going to start right here. This is not the number negative 15. This is the number positive 15. If you took 15 plus 15, would it cancel out? Does it zero out? No, it doesn't. 15 plus 15 is 30. If you were to do this first step that Katie did, even though it would be legal, you can do it, you sure wouldn't just get 4p on the right-hand side. You would get 30 minus 4p, and even though it would be something true, it wouldn't be very helpful because you haven't gotten any closer to getting p by itself. So that's Katie's struggle right there. She thought that that minus belonged to the 15, but it doesn't. That minus tells us what the 4p is doing. Because the 15 is positive, it's like we're going up. It's like we're adding 15. We have a positive 15. And so to get rid of it, to make it zero out, I need to subtract away 15. Ooh, okay. So we got what Katie did wrong. All right, let's look at Paul's solution. So Paul managed to avoid that first trick that Katie fell for, and I like what he did as his first step. We can see that he chose to not add 15 to both sides, but subtract 15. So good choice, Paul. So let's take a look here at what happens to see maybe he did his subtraction wrong. I don't know. So 15 minus 15, well, that does zero out. Nice. So that all I'm left with is negative 4p. And then we'll do this negative 41 minus 15 in our calculator, because when we're this focused on algebra, you guys, we can make the silliest mistakes with negative numbers. So negative 41 minus 15 does give me negative 56. So look at that. Paul was right up to there. I like that. Okay. And now let's look at what Paul chose to do next. He chose to divide by 4. Now, I partially agree with Paul's reasoning. Let's talk about what was good first. Paul avoided another common error that students make here. He knew that negative 4 and p, they were shoved together, so they must be multiplying. So nice job, Paul, to choose division. But Paul did not divide by exactly what he wants to get rid of. If I want to get rid of a multiplier of negative 4, then I need to divide by negative 4. Okay? If I do what Paul did, negative 4 divided by 4, I'm going to be left with a negative sign hanging out. P won't be alone. P will be negative, and I'll have more work to do. But if I divide from that with that negative 4 right from the start, then yeah, the 4s will cancel, but so will the negative, right? We need the exact same number multiplying and dividing in order to cancel. Okay, so there's Paul's issue. Paul dropped that negative sign when he divided and then just left it like it wasn't there anymore, and that's simply not true. It did not cancel out. All right, let's look at this last student. All right, so Felicia started with that good first step, subtracting 15 from both sides. Nice job, Felicia. And she said 15 minus 15 zeros out, so negative 4p is left here, and looks like she did her work correctly in the calculator. Negative 41 minus 15 is negative 56. So Felicia's good up to here, but look at what Felicia did, the other common student issue when we see a negative multiplying. And that is, she said, well, the opposite of subtract is add. And I'd say, yeah, Felicia, but this 4, even though it has a minus sign in front, it's not subtracting with p. It's not subtracting with p. The negative sign would have to be between the p and the 4 to say it was subtracting with p. But see how that negative 4 is shoved up against p with nothing between them? That says they're multiplying. And so even though negative 4 and positive 4 are opposite numbers, you didn't choose opposite operations. Okay, we move those numbers by choosing opposite operations. The opposite of multiplying by negative 4 is dividing by negative 4. So, okay, we've looked at all these students' errors. What is the correct answer? So let's get as far as all our students got to negative 56 is equal to negative 4p. And now let's solve correctly. So yes, these two things are multiplying, like Paul saw, even though Felicia didn't see it. And so I will divide, but I will divide by exactly the number I want to get rid of, the negative 4. And if you don't trust me, you can put it into your calculator and see what happens. If you do negative 4 divided by negative 4, you just get 1. So that's that idea that we just have one p. We have a single solitary p, and there it is. And now this is the work to do in your calculator. Negative 56 divided by not 4, but negative 4, and we get an answer of 14. Woo! All right, thanks for tracking with me, you guys. We did very challenging work here. So two things. First of all, if you have a question about this, you need some more help with this is pretty challenging, you can go ahead and post it to our Facebook group. But then again, don't worry about problems like this so much. This is a really high level of reasoning, but by going through these kind of exercises, we're developing the kind of math reasoning skills that you really need for the GED test. All right, you guys, happy learning.